the first part of chapter 3, which is a tower of machine learning classifiers using Scikit-Learn. So what we see today is just basically part of chapter 3, which will see how we can use Scikit-Learn to train machine learning algorithms. So you can see here, it says we'll select some powerful machine learning algorithms that are commonly used in academia and industry. So this means that there are tons of machine learning algorithms that are available to use in Scikit-Learn, but we'll just select a handful of them to try to use them for machine learning. We will also look at the advantage and disadvantage of each one, because as you can see, there are many machine learning algorithms. So which one do you use at which time? So we need to know which one is good for us and stuff like that. The chapter will also introduce Scikit-Learn, which is basically the basic library that is used for machine learning in Python. And so this is the overview of the chapter. This one, so we'll do this today. We'll do this today. Maybe these ones, we'll just get the intuition how to do that. And now tomorrow, Sunday, then we can do this, how we can use other algorithms. Yeah. So choosing a classification algorithm. So this discuss about how can you choose a classification algorithm to use for your machine learning. It turns out that there are tons of different kind of machine learning algorithms you can use. You can use support vector machine, you can use logistic regression, you can use decision tree. So we have tons of them, right? But which one do you gonna use to use select, and which one gives better performance? It turns out that no single algorithm or no single classifier works best in all possible scenarios. So for example, if I assume I want to do machine learning to train some data set for head speech or sentiment analysis, not all algorithm that works best. So the best way is try to practice or try different algorithms, use decision tree, use logistic regression, use support vector machine. And while you try these different algorithms, then you select the one that gives optimal performance. So that's why here there is a quote here which said no free lunch theorem. So this is something, a theory which says that no free lunch theory basically says that no single algorithm, machine learning algorithm, works in all situations, meaning no free lunch theory. So let's look at what this theory says. No free lunch. Okay, again, let me share my. We can all see my BS code, right? So.
No. Cool. Okay, so we can see it now.
Where did you want?
No, this is Google.
The 20 doesn't make BS code in October?
I was thinking, oh, you wanted to do some coding. So.
Okay, yanzu da akwai BS code anan ko?
Gashi nan.
Yanzu kuma fa?
Google page.
Okay. So what I want to say is this. This is what no free lunch theory. So if you look at this, what no free lunch theory is, as NLT, a theoretical finding that said that all optimization algorithm performs equally well when their performance average over the projected function. So what this is telling us is like no any algorithm work best in all situations. So you need to change and adapt. So that's what they said in practice. If you are using machine learning, it's recommended that you compare different performance of different algorithms and then select the best one. So if I want to do this, train the machine learning algorithm for a particular problem, then I can train for different, maybe 5, 6, 7, and just select the one that best work well. So that is thing about that. And the performance of the classifier depend only on the data that's available for learning. So also machine learning performance algorithm are actually constrained by the available data. If I have large number of data set and the data is annotated, is really qualitative. What I mean by qualitative is this. So for example, I want to do head speed detection, and now I give people to annotate the data. So these guys say, oh, I Fulani kidnappers. All the Fulani are kidnappers. So you can see this is somehow hate speech, right? So if you can actually annotate the data equally, but if somebody says all Fulani are hate speech, kidnappers, say one of the annotators say one is not hate speech, but one person say it's hate speech. So you can see that the data set is not consistent. So what we are saying here is that if your quality of your annotation is good, your machine learning algorithm will work good. If your annotation is not good, it will not. So even machine learning algorithm depends on the data set you have available. The quality of your data also determines how good your algorithm works. Now, before we go start doing machine learning, what will happen now? There are 5 steps, one step that are involved in machine learning, 5 steps. So there are 5 steps that are involved in training machine learning. Number 1 is when you want to do machine learning, number 1 first, select or collect level training examples and selecting features. So what do you mean by this? The first one. So the first one is the first one here means that collect level training example, selecting features and collect. So what do you mean by selecting features? Now, if I want to do head speech detection, or maybe sentiment analysis, let me just give the one I'm familiar, sentiment analysis. So in sentiment analysis, so what are the features that makes a tweet, for example, positive? Maybe the president is good. So you can see good means it's something that classifies something as positive, right? This is bad. You can see bad is something that classified to as. So these are some of the features, terms that, so select future and collecting level training data based on this feature. So collect level training data. What we mean by level training data is that your data set is level. We know supervised learning works with level data sets. Choose performance metric. We'll come to this. What we mean by performance metric. Now, if you do train machine learning algorithm, how do you find out the machine learning algorithm works really well? That is performance metric. When you choose your performance metric, the next thing, choose learning algorithm and training model. Choose the machine learning algorithm you will use. Evaluate the performance of the model. Now you evaluate the performance after you do training. After you train, then evaluate, see how it goes. Then change the setting of the algorithm and tune in the model. So now when you evaluate the performance, you see, oh no, the performance is bad. Then you can change the setting of the algorithm. So there are many hyperparameters that we can tune for the algorithm. So yeah, so there are many what we call hyperparameters that we can tune for the algorithm. So these are some of the 5 main steps here highlighted that we can use for training machine learning. Get your training data, choose the performance metric, choose the learning algorithm, evaluate the performance. When you evaluate the performance and the performance is not good, change some of the fine-tune the model. That is, send the algorithm and tune the model. So that's what we're going to see, this kind of 5 steps to see how we can do that. Yeah, any question before we go on? Any question? Okay, so now let's move on. So let me just recap what we discussed last week, because the book also recap. What we mean by this recap is we basically gonna see how we can train perceptron. Then we can quickly move on into introduction of Scikit-Learn. So remember, last week we trained a perceptron. A perceptron is a learning algorithm that actually inspired the work in machine learning, where we start doing training machine learning model. Remember here, this is what we generate the data set here in perceptron, right? We generate a data set which is from this stuff, and now this is the data set. We have the data set is 100, and now we have two features in the data set. So this is something we train. Remember here, we do shuffling in the data set, right? We do shuffling. And now here we assign something as X train, X test. And now here we assign something as Y train, Y test. And now here, remember, yes, last week we say we do normalization, right? So this is something we said we will see today, how this is being done with Scikit-Learn. So just to remember us, here is we create a data set, random data set. We assign what is X, which is the training futures, and this is a target. That is what we want to predict. And here we shuffle them because the X is somehow, we need to shuffle the data so that it is not arranged in sequence. What I mean by this is, like, assume we have 100 numbers, 100 training data, or 1 million. So if I have like 0, 0, 0, up to 0 here, now, then I have 1, 1, 1, something like this in my data set, right? So the reason why we shuffle is that if you divide your data, maybe this to be a training, it means that only 0, 0, these features will be the training, right? Only 1 here will be for testing. So the idea is that before we do training, we shuffle the data. So if we shuffle, it will be something like this: 1, 1, yes, 1, maybe 0, 1, so that's shuffling. So this is what we do shuffling. So we'll see today using Scikit-Learn how we can do shuffling. And also, this is how we do what we divide the data. So for example, in machine learning, when you do machine learning, we want to do machine learning, we divide our data set into 4 classes. What do I mean by 4 classes? We have what we call training data set, right? We have what you call training data set. Okay, we have, training. So for convention, what we use we call training data set, we call it big X for convention. And target, we call the target as Y, small y. So this is by convention how we do. Training data is called X, and target is called Y. That is why here you can see we use capital letter to how about training data, and here will be the target. So this one, let me show you this. Remember last week we do this, but I'm just going over it. So let me show you the Y and X. Do I have them here? Okay, let me this again. Yes, yeah. So you can see this is my training data, right? I have 2 futures, 1, 2, right? And if you look at the Y, Y, do I have the Y? Yep. So you can see this is my Y. You can see this is a prediction. So we want to, given any of these combination, we want to predict whether this is a target, whether it's 0, whether it is 1. So this is how we do machine learning, as we already know. Given data set, we do prediction. Anyone with question? Anyone with question? Haris, yau mun ganka kenan. Kwana biyu.
Lafiya lausa, ba lafiya ba dai.
Allah sarki.
Yeah. So any question? Okay.
My question is just kawai last week video, did you share it, Star?
No, ban share in shi ba. So
okay,
I will share. So here
I missed the class. So
okay. So I will share. So this one, just to tell you, we just create a data set, random data set. But you remember, if you are going to do machine learning, we are not going to create a random data set. We will be given a data set. So we create our X. Now here we do shuffling, and now here we create a trend set.
Sorry, Allah. Just one question.
Yes.
That's the data equal np.generate from text. What does that mean, please?
So here we explained last week, because you are not here last week. And so here it just generate this one. Are you talking this one?
Or no, this? The first line. First line
okay.
in the
okay. This one we use it to read our data set. This is perceptron.txt. This is a data set that we read using this np numpy function that we can use to do that. So you can see here.
Okay, so
you can see what this is.
You are reading
load data from a text file with missing values. Yes. So this function allow us to load data with missing value. So yeah, I
Okay,
mean,
can you achieve the same thing using pandas?
yes.
As
But
in-
for NumPy, yes,
Okay,
for
okay.
NumPy. Yeah.
Okay, too. Okay.
So here we shuffle our data set, remember, and now here we create train and this. So what we mean by this, I said training data, we normally by convention, we use capital S and Y, but remember we divide our data into classes, right? If we want to do machine learning. So what do we mean by this? So if, for example, I have this data, which is 1, 2, 3, 4, like this. And now I want to, okay, maybe, this example. Let me give an example. Train test split, right? So yeah, so you can see this is our machine learning data. If we want to do, yes, this is a good example. So if we want to do machine learning, this is our data set first, this big one. So this is our data set. You will be given our data set full. Now, how can you divide your data set first? Now, full data set, it must have your futures and the target, what you want to predict, right? Now, these futures, we need to divide them into 2. That is for training. We divide the commands. You need to take some part that will train our model with this part. And now this part will be used to test the performance of our model. So this is how it is done. So you can see that if you have a data set, a single data set now, it will be divided into 4 classes. This one, we do like this. The top one will be for training. This will be Y train. So you can see we have X train, Y train. We have X test, Y test, meaning this will now be for testing, and now this will be used for training the model. So this is what we are doing here. If you remember, we define our data set X train, X test. So this X train, X test, this is the one. Y train, Y test. This is a Y train. Okay, X train, X test, Y train, Y test. So this is what we divide. And now we do what we call normalization. Last week, remember, we do normalization. So this is just preparing our data. Just to recap. Now, we create a perceptron. Remember, we define what perceptron, how perceptron works. So you can see here, let me quickly go there. Yeah, this is how perceptron works. We have our weight, we have our bias. Now we sum them here. We have a threshold and we do prediction and we sum the errors and now find the difference between our prediction and error, right? In last week, refer back to previous class last week where we do this. So you can see we implement a class perceptron. We define forward class, backward, we do the train and we evaluate. So now we define perceptron algorithm. So what is perceptron? Perceptron is basically an algorithm that can do classification for data set. So here we just write the perceptron algorithm. Perceptron algorithm, and we explained it last week, how we find this, everything. We text us a detail of time, how we implement this, but this one, we get the intuition. Now, let's look at it. So this is our data set that we created, this one, X-Train and Y. This is the data set we just plot here. Can you see them? We call them X-Train and Y. We just plot them just to see. So we want to train a machine learning algorithm that can classify this data set, right? To classify this, to say, okay, this is this data set, this is this data set, this is class 0. So we will use what is called perceptron, which is what inspired us to start doing machine learning. Now, how can we do that? For you to do that, you just create your class that you created, which is this perceptron. Can you see that? Remember, the perceptron, to initialize it, you must impute the number of features, right? So here we call perceptron. We call number of features we want to use is 2. Then we can see we create an object called ppn, perceptron, right? Now we create perceptron. Now, how can we train? For us to train this model, what we need to do is just to call perceptron, because you can see in this perceptron, we have many functions. We have a function called train. We have a function called evaluate, right? Now, in Python, if we create any object from this class, so if I create any object here, A is equals to perceptron, maybe I have, I say, okay, 2, number of features is 2. When I create this object, which is A, I create this A. Then if I want to access any function from this class, I need to use this object that I created. If you remember A, then I need to say dot. Can you see that? I need to say dot. Now, when I say dot, I will be able to access the functions in this class: train, evaluate, back forward, forward, and stuff like that. So the moment I put dot, as you can see, when I say A dot, can you see A dot? Can you see? No. You can see if I run this guy, when I say A dot, it shows me, I don't know why it's not trying to show me the A dot. I don't know, like
kai amfani da capital P ne
eh?
a perceptron na ce kai amfani da capital P ne.
Yeah, P.
Okay.
Let me just use it again. So A is equals to perceptron, right? I have, can you see I have an object called A, which object called perceptron. So for me to access any function here, I need to call A, the object A. I can say A dot. Can you see maybe I want to access maybe evaluate trend. You can see oh, I thought, I don't know why it's not I suppose like to see I tab. When I put a tab, it will show me the possible method for this object, but I don't know why it's not showing. Anyway, the point I want to say is that I can now access method this. So I need to use the object, so I can say A. Oh yeah, look at them. So you can see my backward, my bias, I mean my evaluate. I mean, you can see this is a method, this is a method, this is a method. You can, this trend is a method. You can see them is different from this, right? You know, so I can call trend to train a model. I can call a train method to train a model, because this class perceptron is the one that implemented the object. So yep. So where am I? Do I cancel my? Excuse me, just a minute. Okay. Right. So here we train our model. So here we I run my class. Now I want to, I don't know where I bring this guy. Or maybe I copy it. Oh, I copy it from here. This is duplicate. So let's see that. So here I just plot the data set to see the data set. Now this is what I want. I was saying. Now I want to create an object from this class. Now I say ppn, which is perceptron, but I want to create access this train method, so I can train my data. So now here you can see I said ppn, because this is the object. I must call this ppn dot train. Then I can put the x train, y train, right? And the epoch, number of round I want to train the perceptron. So this is it. Now we can see here we train a perceptron, and now we can see the weight and bias, right? Now we say, okay, how can we evaluate our model? So remember here, you can see the perceptron here. I use X train, Y train. As I showed you here, that I want to use X train and Y train to train machine learning model, right? So here I train the model. Now what else next is to evaluate the model to see its performance. Remember, we highlight the steps that we're gonna use for machine learning here. You can see select the features or training class, select the performance metrics, evaluate the model. So here you can see here we have a method called evaluate that evaluate the performance of the perceptron. So we can call the model. So here we cannot also just call evaluate. We cannot call evaluate to evaluate the performance. No, we must assess the evaluate method through the object ppn that we created. So that's why here we said the object ppn.evaluate is assessing the evaluate method. Now when we run this guy, what is happening? Okay, so run everything, Manama. So when we okay, let's go back. Run this guy. Run this guy. Okay, we train the models. That is the training here. We evaluate the model. Oh, torch, where I'm bringing torch. Name torch. Do I call torch here? Ah. Oh, sorry. Yeah. Oh, okay. Yeah. So there's something I missed here. So here, basically, I remember last week we didn't use the example for touch. So this one I'm using showing us the implementation of Pytorch. So here, this one is still the same thing. I will change it. It's still the same thing with the implementation of. I don't know how the Pytorch implementation here comes in, but I remove it and put the Python one. Let me just go back and see what happened. Anyway, let's continue. Let's continue. Let me bring it back. Remember, this is just we discussed this. This is just I'm trying to go over what we did last week. Yep. Let me bring it back. Anyway, so let's move on. So this to evaluate evaluation purpose, for us to assess any, I don't know, even the evaluate here, this VS Code sometimes, oh, it's not bringing this thing back to me. Redo again. Redo again. Oh, it's not bringing back the code. Anyway, so let's continue. We discussed this already last week. So what I'm saying here is that we want to evaluate the model. For us to evaluate the model, we must use also the object and now call this method. So this is what we discussed last week. Now, what we want to do this week is how can we use, we basically use the Scikit-Learn. Now, the easiest way, so we don't need to suffer how to use this stuff. So don't forget about implementing Scikit-Learn. Just abstract all those steps. Now, we'll take a look at the Scikit-Learn API that comes with user-friendly and consistent interface that allow you to create a machine learning model. And many machine learning models are available with Scikit-Learn, and it allows you to do all this pre-processing that we discussed there. So let's look at implementation of perceptron via Scikit-Learn. So let's just implement the perceptron we saw just now via Scikit-Learn. Now, we will use the same data set that we use, iris data set, to train a perceptron. Now, we're gonna import the data set. Remember here, we just create a random data set here. Can you see that? Like we create this toy data set. But what we are going to see here is we are going to use a data set from iris data set. Now, that is why we said from Scikit-Learn import dataset. What this means is that dataset class in Scikit-Learn. So you remember this is how we import a class. So dataset class in Scikit-Learn has inbuilt several datasets that you can use. But now we are loading iris dataset. So here you can see from Scikit-Learn import dataset, and now here we import NumPy. So we want to load the dataset. We said iris dataset because this is the class. Now we can say dataset dot load iris. So if I want to load another data set, I can say x is equals to dataset dot load. So you can see there is a lot of data set. You can see them, news group, Can you see many data set? load Boston, load breast cancer, diabetes, digit, iris. You can see this iris. So there are many data sets that are implemented in Scikit-Learn that just allows you to do that for practical purpose. So here you see for practical purpose, we are loading the iris data set. So if you want to try another one, you can try that another one data set. You can see that load any data set you like. So here we are loading iris data set. So we load iris data set, and now we said, okay, after we load the iris data set, let's see what it looks like. Iris data set. Let me see. Can we see it here? Iris. Okay, it is in this format. So we have the iris data set. So here we can see that we are actually subsetting the iris data set. We said, okay, the data set, iris, the data, all right, give us the whole data set, and now these columns are the let's see it like this. Okay, so you can see here we assign the, let me show us this guy. So if we call this guy iris, so this look at this is the format for our data set, right? This is the format of our iris data set. Now, if we want to convert this to data frame, who can help us to convert this to data frame? If I want to see this output in data frame. Okay, so just want to
simply call, okay.
Go on.
So for us to convert this to data frame, we have to import pandas.
Yes, okay. We can use pandas, right, to change the data frame so that you can see it vividly. So you can import pandas basically to do that, to be able to see that. So I just want to show you how the structure of that works. But now what I'm trying to do is just we assign these training data to X, our training data. Can you see that? And now we assign the target. So yeah, let me show you the iris first. I don't want to. So you can see here we have something like this. Can you see called data, right? And in the data here, and now can you see here something like we have what is called target. So there is another thing. Okay, let me see this here. Okay. Yeah, so the way it looks like, let me look at it here as well. Oh yeah. Okay. So what do you call it? Sklearn. There is what is called the data type. There is what is called bunch data type. So let me show you something. Sklearn data set class. There's one I want to show you. Yeah, so this is the data set we are working on. You can see the classes iris, this is the STOSA, this is this, a number of instances. We can see that we have 150, and now number of attribute, we have 4 numeric, which these are the numeric number of attribute, predictive class and the classes. We have this, and this is some of the summary of the data set. Okay, they didn't mention it here. So I want to talk about something called data bunch, but let's move on. So here you can see here we use print class level np.unique y, meaning that here we find the target. How many target do we have? We have 0, 1, 2, 3. That is, we have 3 classes. We have, as we saw here, we have 3 classes, which are basically iris, satosa, iris vascular, iris virginia. So you can see here now the Scikit-Learn implement this data is not using categorical variable category. So these categorical category are now changed to somehow kind of value. So you can see, although many scikit-learn function and class method also work with class level in string format, using integer level is recommended approach to avoid technical glitch and improve computational performance due to smaller memory. Furthermore, encoding class level as integer is common convention among most machine learning algorithms. So what this is telling you is that this is a data set. You have these 4 features, but the class level is in categorical variable. So if these are the features, then you predict it's setosa. If these are the feature, you predict. But for us to be using this categorical, what is done in machine learning is you can represent setosa as 0, vesicular as 1, Virginica as 2, right? So this is what is happening. You can represent these guys, setosa as 0, vesicular as 1, Virginica as 2. So meaning instead for you to do this prediction with this categorical variable, it's better to use with numerical to change this. So if you have a data set, you want to do prediction, maybe sentiment analysis, maybe positive, negative, neutral. So it's better to convert the class level from positive, negative, neutral to 0, 1, and 2. So this is the reason. Also, you can see many scikit-learn function and class method also work with class level in string format. Using integer level is recommended approach to avoid technical and improve computational performance. Encoding class level as integer is a common convention. So this is something that we should know. Yeah. So any question? So what I'm saying here, you can see here in just how many lines here, we divide our data set, we just call it here. So any question? So you can see here, the iris setosa is represented now here as 0. Iris vesicular is now 1, and iris virginica is now 2. So this is just it. Now we want to do splitting the data into 70 and 50. So if you remember here, where I create, this is how we do some kind of splitting the data. Remember here when we create a random data set, this is how we do the split, you know, something like this, which is not convenient. And shuffling, we need to do shuffling first. We need to create some kind of random numbers and do shuffling. And now this is, so now all these steps, can you see them that we do can now be used scikit-learn in few steps. Now, this is how we can do it in scikit-learn. So in scikit-learn, this kind of splitting and, you know, all this is now implemented in what is called trend test split function. And trend test split function is under...
Sorry, please, just
Yes.
a question, sorry.
Yes.
Hello?
Yes, go on.
Yo, I don't know, is it my phone or what? The audio is lagging. You know, skipping, you know, I can't hear well because it's just breaking. I hear you
Okay.
some part and then
Okay.
I don't know, maybe it's from my side.
Okay. JJ, can you hear me vividly?
It's not that I cannot hear, but breaking yake.
Okay, the other people, am I breaking?
Maybe ko daga wuri na ne.
Other people here, can you hear me or am I breaking?
Yes. Okay.
Okay, so in Ajina, maybe something but
Hey,
Your voice is
let
okay.
me reconnect gaskiya ni wallahi kawai haka sinsin. Let me reconnect and see if
Okay.
that will help.
Okay. So we can see here, we want to do this split. So we will import a function called trend test split from model selection. So from scikit-learn and under model selection, import trend test split, right? So remember here, we will divide our data set into 4 classes, as I mentioned, which are these, X trend, Y trend. One and now about X trend, Y trend is we do training, and X test, Y trend we do train our model, validate our model. So how do you do that? Now what you need to do is just, this is X trend, X test, Y trend, X test, Y test. We need to put these 4 things in order the way they are here. This is how the function does work. So what we mean by this is that, remember in machine learning, in Python, I can see A, B, C. If I say, okay, assign this 3, 2, 1. So meaning 3 will now be assigned to A. 2 will be assigned to B. 1 will be assigned to C. If you change the position now here, A is here, B is here, then 3 will still be assigned to B, You see, you change their position, right? So for us to do split our data sets, trend test split, your data, you need to put your data set in this format. First, you said your X trend, then X test. Normal convention, you'd say train, you divide your training data. That is your future. That is the future, which is this one. Can you see that? X train, this guy, and X test. I mean, X train, which is this, and X test, this guy. So you put them here. Now you go this guy, Y train and Y test. You put them here. Y train, Y test. Now you just call your function trend test split. Now, trend test split, what it does, you can see split arrays or matrix into random trend and test subset. So now what you need to do is just put your trend data and Y, your target, and now you specify how are you going to split your data. We say 0.3, test site is 0.3, meaning we're going to split our data into 70% to be training. Test size is 0.3, meaning training size is 70%. If test size is 0.3, meaning this side will be 0.3, which is 30%. Automatically, this side will be 70%. Now, random step. So here, random step, what we are doing is that we are using a random state where we are saying, okay, use one, meaning when we now, I run this, the next time I run, the same splitting will be assigned to Xn, Xn, Yn. If I don't use any random number, when I run this X trend, Y, I run this, the next time I run, different value will be assigned to X and Y trend. So the idea of this is use a random number so that it will it will preserve the values for the next running if you run this something. Now here we have what is called stratify. So let's look at what we mean. So now if you look at this function, so let me do this, help. If we go this trend test split, I just use help command to show me. So what this function does, you can see trend test split, it has many text size, trend size. So here you can see we just use test size, which we say is 0.30, right? We didn't use trend size because if you use test size to be 0.3, automatically you don't need to provide trend size. It will automatically be used, right? And now we provide the random step. We provide the shuffle. So you can see here, I didn't use shuffle, right? Because shuffle you can see is true. So it means, remember here we use shuffle while we are creating. Now we shuffle our data set, right? We shuffle. But if you are using Scikit-Learn will shuffle the data. Well, the moment you call this function will shuffle your data because it's true by default. And we have what is called stratify. So what is the meaning of stratify? The meaning of stratify is this. It makes sure that, so what the meaning of stratify? For example, if I have a data set like this, maybe I have a 0, 0, 0, 0, and I have another maybe I have another one like okay, let me use this example. So for example, X train. Okay, let me just use, this is my X. So let's assume this is just my X. Right? This is my S. Now, if I want to divide this data set, for example, into X train and Y train, or X train and X test. S test. Now, I want to select some part of this data. So for example, I can take, after I do shuffling, I can have something like this here, 0, 0. And now here I may have something like this, 1, 1. So let's assume here you do shuffling. Even though you do shuffling, there is chances or probability that after shuffling, you still have your data set in this format. Now, what is the meaning of stratify? Stratify will make sure that the classes that are represented in Xset, they are equal, meaning I need to have 0 and 1 and 0 and meaning the equal number of 0 and 1, we have equal number in Xtrend and Xset. That is what stratify means. So if you can read this stuff, yeah, okay, I have this something like this. Note that the train test split function already shuffled the training data set internally before splitting. So you can see this train test split, this function split the data set before splitting. Other all example from class 0 and class 1 will have ended up in training data set, and test data set will consist of 45 examples of this. So the reason why they said this is remember, this is the data set we are working on. And the first set of the data set setosa is from 1 to 50, they are all setosa. From 50 to 100, they are vesicular. From 100 to 150, they are vaginica. So you see, if you just divide your data set, maybe 70-50, then the top one will only be setosa and vesicular, and the test will only be vaginica. So the shuffling makes sense. So this is what they are saying. Yeah. Also, we use also stratify equals y. In this context, stratification means the train test split method return training and test subset that have the same proportion of class level at the input data set. So this means that the training and test subset, they have the same proportion. So what this is telling us that the training and test, they have the same proportion of the data. So that's why we use the stratify. Right, so you can see here, we basically split our data set. So what is next after we split our data set here? Remember, we split the data set and we do normalization, right? So now we can do normalization with Scikit-Learn as well. For us to do that, yeah, so this is some of the thing we already show that the data set now is divided. You can see we have 50-50 of equal of the classes. We have setosa, the scholar 50-50. But the level in Y trend. So you can see I have 35 of this guy, 35 of this guy, 35 of this. And now I have 15 of this guy, 15 of this in the Y test. So this is what why this is the representative of the stratified that I explained. Meaning class, the first class, which is setosa, I have 35 sample. The second class, which is whatsoever the second class, vesicular, I took 35. The third class, basically the last class, I took 35. And now you can see in the level of test level, I have 15-50. So this is what this do this is this stratify. Stratify. We say stratify, we provided the test set. Remember here, this is the target. So stratify, we provide the strat based on the target, meaning that this. So you can see this is the something that they want to show us. Now, finally, we want to do scaling. So Scikit-Learn comes with a method that can do function that can allow you to do scaling as well, which is under what is called standard scalar. So if you look at this, it means Scikit-Learn bring everything under some stuff is consistent. So here is under what we call pre-processing, because this is pre-processing. So we import pre-processing. Much the same here, we can see we import our iris dataset, import dataset. Now we create object called iris. Now for us to create functions or other stuff under iris, we need to call this object. So this is also still the same. Here we import standard scalar. Now we create standard scalar object as standard scalar object. You can see that SC. And now we fit our data set now. Now this is fitting. So remember here we do fitting. When we do the previous session, we do fitting, we call fit. You can see here we create our object called perceptron, and now here we said train. So in some ways you can see training a model, you see train. Sometimes you can see fit. So people use this interchangeably. Train means to fit the data. So some function, some people use train. So here we would have used train here instead of fit. So I can use fit means to train the model. So when you hear people saying, I'm fitting the data, they are saying I'm training the data. So here you can see here in Scikit-Learn, there the different we call train. So in Scikit-Learn, what we'll be calling to train the data is fit. Can you see that? So that is it. So you can see we fit the data, but here what we are doing is we are not fitting the data for training, but we are fitting the data to do some kind of standardization, because this is an object we created, which is standard scalar. Now we want to fit this scalar on training data, and now you can see standard scalar has two things. You need to fit and transform. So you can see, let me go back the previous stuff. So you can see here where when we do the normalization, we basically create the mean and divide by the by standard deviation. Okay, this is the xn mean and standard deviation we assign here, and now we say xn is this xn minus mu, which is mean divided by standard deviation. This is how we create xn, and this is how we create stat. That is the stat minus mu, which is mean divided by sigma, which is standard. This is how we do normalization. We understand the importance of normalization. Giving you a data set, it is good for us to do normalization, to normalize the data so that it is in some kind of range. So that's what we do here. That is what we do here. Yeah, we normalize our data set. We create an object called SC, which is standard scalar, and now we fit our trained data. Remember, this is our trained data, and now this object still XC that we fit. So we have XC that we fit. We call this object still SC. You call a function called transform, and now you provide your trained data. So we now have X3 standard deviation, X standard deviation. So you can see you now normalize your test data and you normalize your trained data. So when we are doing machine learning, the data we are normalizing, we are only normalizing these guys, X train and X test. We don't normalize Y train and Y test, this column. We don't normalize these guys. We only normalize this. So this is what we normalize. So here in future, when we want to train the machine learning, we will no longer use X-train and X-test, but we will use X-train STD and X-test STD. Any question? Saminu? Oh, he's not here. So yeah, so that's yeah. So the first thing we can see that after we load our data set, we do the splitting of our data set. Now we do normalization, and normalization allows us to transform the data into some better way for the model to learn. So our machine learning model understand best when we normalize our data sets. Yeah, just keep in mind with this. Our machine learning model understand best when we normalize our data. So how can you do normalization in Scikit-Learn? We import this, we create an object, standard scalar, and now we fit the train, the data set, we fit it. Now after we fit on train data set, now we can transform on X-train and we can, so this is it. So note that we use the same scaling parameter to standardize the X-test data set so that both the values in the training and test data are comparable with one another. Okay, so now we normalize our data set. The next thing is to train the model. Now, how can we train a model? Now, Scikit-Learn implement a lot of algorithm to do that. So here, this is from sklearn.linear model. So sklearn has a lot of stuff, but we are importing linear model from sklearn linear model, import perceptron. Remember, we are going to use perceptron. There's some way we do that. Now you can see here, we said, okay, perceptron network. So you can see perceptron, because this is what we import. Now we put ETA, which is learner rate, random state is 1. So you can see this is looking the same as we did when we did last week, where we create our algorithm called perceptron. Here you did it, you see it, and now here this is how we do it, right? Perceptron, number of features and stuff like that, the number of epoch. So this is implemented in Scikit-Learn. So you don't need to do that. So now you can always call your algorithm from Scikit-Learn. So here we import it, we say perceptron, we give some kind of parameters, learner rate, random step, and now you can see we train the model, we can fit it. So here, this is fit. So for us to train the model, we call this object VPN. You can see that we fit That is, you provide the X train STD, that is the X that we standardize, and now we provide the Y train. So how can we fit a model? We remember, for us to fit a model, we provide the train data and Y train. So this is what I mean. X train for training this value and this value, Y train. That is the futures and the target. Futures and target. This is what we need to give to the model for us to train the model. When we want to evaluate the model, we want to see its performance, we try with these guys. So now you can see here, we give it X train, but the X train, the X is the one that we standardize. Remember, we standardize this part, this section, right? So we give it this one, and we provide this one, and now we click this, and now you can see we train the model. Yeah, so any question before we continue? Okay, so now we can see we can do prediction. Now, since we fit our model, we can do prediction. How can we do prediction? For us to do prediction, we do prediction on X state that we standardize, right? Right. So we call PPN this object. Remember, PPN.fit, that we fit our data. So we just call this object PPN.predict. Now we call our test data, and now we can see that this guy is here. So we can see, and we do that. And now here we do what is called try to find out, because it's a classification where the X test is not equals to the Y pred, right? X test is not equals to the Y pred, and we sum them here. So here is a prediction, and now we can see the algorithm is classified. Only one example, right? Now, that is what happened here. We can see that the algorithm is classified. We can see that the perceptron classified 1 out of the. So what is this Y test? This is our Y pred, the prediction we did. Now you can see Y pred and comparing it with the Y test, the prediction. So what we did here, remember, we train this. Now we do this training, right? And now I said, okay, let me do prediction. This is the X test. Given X test, I predict. So if I predict on X test, then I will predict the value of Y test here, right? Because I want to predict the value of this one to give me this. So this is the prediction. So I want to compare with X test, the real value. Is it what I predicted? Is it the same thing? So I do this. Y test is not equal to Y pred. That is, I'm comparing them where they are not equal and sum them. So instead, it's only one place that is not equal. So we can see that the perceptron misclassified 1 out of the 45. For example, that misclassification error on the test data is approximately this. So we can see here, we find what is called misclassification error. So, but there are many things, there are things that you can do, not misclassification error. We have what is called accuracy to find your model. So here you can see still in Scikit-Learn, we can use accuracy. So here you can see under matrix, we can download accuracy. So we can say print accuracy, accuracy score. Then we put the X test and Y pred. That is what we predicted here. And now the original Y test here and prediction. So you remember, this is the original ground truth, and this is the prediction. So when you call your accuracy, it tells you that you are accurate 0.978. So you can see here, we show that you can basically use 2 different kind of things. The number one, we can use what do we call it? Classification error. This shows as classification error. So some people can use classification error, and some people use accuracy, but we always use accuracy, so don't bother about this. So this is the accuracy we use. Now, yeah, so classification error versus accuracy. Instead of misclassification error, many machine learning practitioners report classification accuracy of the model. So how do you calculate classification accuracy? So classification accuracy is just 1 minus error. That is what is given. And now here we plot the choose what this is doing. Okay. Yeah. So here is just trying to plot some of the stuff. So you can see here, this is the plotting. The data set, it classifies data into three, because this is three classes. So we have class 0, class 1, class 2. You can see it classify. It shows us the region, right? It does classification if you look at it. So this is something that we can see. Okay. Right. So putting it all together. So if you want to train a machine learning and you have a data set, how can you do that? So I put all the code here. The first thing is prepare your data set. Now here, because we are using the built-in data sets from Iris, so we download the data set. Now, after you download the data set, what do you need to do? If you have your data set ready, you need to split your data set into XN, SZ, which is this step, right? Now, after you split the data set before you do training, what do you need to do next? To shuffle your data set, standardize the data set, which we do this one, standardize the data. Now, before we, after we standardize our data set, what do we need to do next? What we need to do is to train the classifier. So this is how we train the classifier, right? And fit the model. Now, how can we do prediction? Now you call predict on this. That is this. Now, how can we finalize the model? That is to find accuracy. This is how we find accuracy. So this is thing, and sometimes you can see that people, if you want to, you see that, you will see that all this we downloaded here. So here, this first guy will now be at the top. You download, you import everything you want to do. If you want to do standardization, you import it at the top. If you want to do model selection, and this guy, you import it at the top. If you want to do any model you want to do perceptron whatsoever, any algorithm, you import them at the top. If you want to use accuracy, you import them at the top. So now this is the first thing you should do if you want to do machine learning. Now, you know you want to standardize your data, right? Import what you are gonna do using. You're gonna train test split, import that. Which algorithm are you going to use? Import the algorithm. Here we say we are going to use perceptron. Accuracy measure, import the accuracy measure you want to do at the top. Now you start putting your code. So this is basically a brief structure on how we can use Scikit-Learn to train our machine learning algorithm. Any question before we move on? This is really critical for us to understand these steps. Any question? Malama Murja, any question?
Doctor, no question.
Okay, so this is actually how we can train machine learning algorithm. We can see here. Can we do better? So, yes.
Wani
Yes.
lokacin za ka iya samu data, misali kamar akwai wata data da na samu haka zan ɗanyi practical da ita daga IITA, wani Institute of Agriculture,
Yes.
International Institute of Agriculture, wanda suke dan bayan gidan gwamnati. Suna da data set haka a shafin su na wanda suka shafa ayyukan noma.
Okay.
To amma da na samu data haka kuma tana da ɗan yawa kusan 1,000 da wani abu.
Okay.
Kuma na ɗan duba haka na ɗan yi haka visualizing da Seaborn Fair Plot.
Hey.
Amma sai na ga pieces ɗin nan ga nan dai a hargitse gaba ɗaya. Wallahi wasu sun yi gida nan, wasu sun dare kasa fahimtar ma ko me a haka dai na samu na ɗan yi. Akwai wasu categorical data na yi one hot encoding haka irin kamar location ne a guri suka yi irin masara ce haka suka yi.
Okay.
To location din na yi one hot encoding haka, amma ya ƙarshe dai ba abin da wajen ina da sama da 65.
Yep. Right. Yeah. So when you are working in machine learning, yeah. So people says data set, getting a good data, 80% of, because like now, if I want to do training, time to prepare your data, put in a good job, it will take you like 20% when you are doing machine learning. 70% of your time will take you to prepare a good data set. Because if you don't have a good data set that the model can learn, you are just wasting time. So the first thing is one makes sure that the data set contain useful information for the learning algorithm, for the algorithm to learn, right? And make sure that if the data is annotated, it's qualitative. And the first thing is, before you start doing even training machine learning, go and visualize the data. For example, here you can see we visualize the data with, oh yes, it is separable, right? But not all data set will be separable, right? You may not separate it, you know. So in particular, perceptron cannot be used to train a data set that is not separable. Perceptron can only be used to train data set that is separable. So we'll see next that other algorithm that can be used to train any machine learning that is not separable. So my idea is that whatsoever you are doing, Palu, just spend time to create a good data set. If you get the data set from somebody from somewhere else, which is not good, it's not your fault. That data set cannot be used to learn, to make a good learning. So it's not your fault. You are not the one that created the data set. So maybe you need to put more effort to see if you have the knowledge to create the data set, better data set. So that's just it. But to better understand, to better reiterate, data sets is the first step that one can spend maybe 60% of his time, because all these algorithms, if you want to use machine learning, all these algorithms that are there, just call them to train the model. Only you, yeah. So that is it. Hello?
Collaborating kenan saboda wani lokacin aka rasa domain knowledge. Haka
Yes.
irin banda yawa. Kaga sai dai collaborating kenan da
Exactly. So domain knowledge, person that is developing data, they are the one that can tell you what this and help you to get more sense about the data. Because if you are working maybe on agricultural data set and you don't know a lot of it, you will not learn. So that's the best machine learning expert or data science expert is the one that know machine learning and the domain knowledge. For example, somebody that is working on classifying disease, which is maybe asthma or asthmatic, maybe he's a medical doctor and you're not more practicing machine learning. So this is the best person because he has some data, he has some futures, you know, all those things. So yeah, Zaradin, what do you say?
Yawa na ce sam irin similar akwai wani wata data set da nake da na gwada da sensor ne a collecting data set din. So ni ma na gwada model babu ya kasa learning, also na yi ta trying na pre-processing, na yi visualizing. So amma ni ma haka ta tunanin to sai nake gani akwai wani video na Andrew NG yake magana issue na high variance or high bias irin wannan issue na underfitting da overfitting, haka dai fara wannan ni ma haka ta ringa mu models biyu kowanne na gwada baya iya ma learning.
Yeah.
Model din ba in ka training baya
So
learning.
one good thing is this, don't worry, the next chapter of this book club is chapter 4, building a good data set. Building a good data set. So this is the next chapter of this book, building a good data. So how can we have kuna ganin littafin?
Yeah.
So can you see chapter 4, building good training data set? Because when you are doing machine learning, if you don't have good data set, then you will not do anything. You will not learn, you cannot learn. So this, you can see they dedicated a complete chapter, how you can build a good data set. So we will learn a lot in the data set in this chapter, I think, how we can build a good data set when we come to this chapter. Yes. Can you see my VS Code now? Can you see my VS Code?
Please, Doctor, I'm gonna share an book. Yes. Dr. Shamsu.
Hajiya baki da littafin?
Ai ko dai ni dai ban da shi.
Da akwai wanda a cikin group din nan ba shi da littafin? Okay.
Wannan machine learning ne with Scikit-Learn and Pytorch?
Yes.
Ina da shi.
I'm asking anyone in here in the book club bachelor sheet.
Wannan dai da muka fara ina da ku.
Wannan da muke yi.
Ina da shi.
Okay, so I will share it with Malama, then share it inshallah so that you can have it. So
Okay.
yeah. Okay. So idan ma an ba ma karanta littafin, okay, can you see my video studio now, VS Code?
Yes.
Okay, what about now? Can you see my VS Code?
Yes.
Okay. So now that is the first thing we do using Scikit-Learn to do that. But there are a lot of other stuff here using a lot of theory about modeling class probabilities via logistic regression. I think what I would do is I will jump into, because we don't have time, I will jump into the using Scikit-Learn to do logistic regression. But the main idea of logistic regression is that logistic regression is a machine learning algorithm that also used for classification. So you can see that it is called logistic regression. It's not regression giving you numbers, but it's used for classification. So let me jump, maybe tomorrow, maybe if there's more time, I will explain much better about that. But they do implement the logistic regression using like the way we implemented perceptron manually, and now they just call it. But let's look at it. So let's train logistic regression using Scikit-Learn. Now, for us to train logistic regression using Scikit-Learn, what do we need to do? Remember, I said, as I explained previously, we need to import our algorithm, right? Which we're going to use logistic regression. Now we create an object using logistic regression that we, But this logistic regression has a lot of parameters or hyperparameters that you can tune the model. So you can see here, we have something penalty, we have something dual, we have something float, we have something fit intercept, we have something to intercept scaling class. They all have their meaning. But here you can see we have something called C1, we are using something solver, we are using something multi-class or over. So we'll see what this means. Now, because we are using multi-class classification, so yeah, so for example, here you can see when I put here logistic regression, you can see here what are some of the parameters we have. So the first one is penalty, L1 or L2 that you use for regularization. We have what is called C, which is also regularization parameters. We have classway, random state, solver. So solver is the optimization algorithm that is used in logistic regression, because we have many optimization algorithms like stochastic gradient descent. But now here you can see we have many Newton, LB, stuff like that. So here we create how we create our perceptron. So remember here, this is how we create our perceptron. Where is it? Yeah, this is how we create our perceptron. Where? Yeah, can you see we create our perceptron algorithm, and now we put some parameters and random state, and now we fit after we create the object, So this is what we're gonna do for logistic regression as well. Why is that? Yeah, so you can see for logistic regression, I import logistic regression and now have some parameters, which is C, which is, there is one called solver, there's multi-class. What is multi-class? Means multi-classification. So if I'm classifying three things or four, I can put this multi-class because I'm classifying three classes, 0, 1, 2. So that's why I say use multi-class, use over, and now the algorithm use LB, you can select any one you like. So how can you know which one you are going to use? You can select them from here. So you can see solver, which one you can select, either this or this or this or this, anyone. That is, you select the algorithm that you will be used. Yeah, multi-class, we have over, we have multinomial. If the option chosen is over, then a binary problem is fit for each level. For multinomial, the loss miss is multinomial. So there are a lot of stuff. We don't actually go through the theory, but this is it. So you can see we create the object and now we fit the training. So you can see in S train, standard D, and Y train, we fit the model. And now here we just try to show how the models do the classification. So you can see the model now classify this into 3 classes, which is logistic regression. So that is basically how we can use logistics. So if you are using Scikit-Learn, what you need to do is just to change the API, just call another algorithm and just train the model. The other steps are still the same. You can use prediction. So because this is logistic regression, we can call something called LR, which we create the object here, LR. Can you see that? Now this LR, we can call it with predict probab. So what is doing here, the logistic regression, here we are predicting the class of the first 3 items. So here you can see we have 3 items because we have 3 classes. Now here I have this, I have 3 classes, and now I predict the first, what is the prediction of the first 3 classes. So here, because it's using logistic regression, it's using it's using probability. So you can see here I have this. So you can see here the probability that training example belong to certain class can be computed using predict prob method. For example, you can predict the probability of the first 3 example in the data set. So this is the probability of the first 3 example. Now, which class they belong? The first row corresponds to the class membership, probability of the first flower. The second row corresponds to the class membership, probability of the second flower, and the third. So the first flower, this is the probability. And we can see the probability is, this one is higher. So the first flower is, I think, Setosa vesicula and Setosa vesicula and whatsoever. So the last one is the probability is higher. So it means this is the first, this is the data set. If we look at the data, the first ones here. Yeah, the first is Setosa vesicula and Virginica. So the last one is the Virginica. So the logistic regression, what it's doing is predicting probabilities. Unlike other, unlike other ones, we will come back maybe tomorrow to see the theory behind. So it's predicting probability. So this is the probability for the first example. We have, it's a 3.0, you can see it's minus 0.9. So it's 0.03, here is 0.14, here is 0.85. So you can see 0.85 is greater. So it means it's the third, which is that one. And we can see here, the second and the third, it is this probability that is higher, right? So this means that these are the first class. It will not. So what it's saying is that in logistic regression, we can call this predict prob to show us the probability of whether an object belongs to a class. But we also have the, we don't use this quite often. What we use, more or less the way we use predict. So if you call your predict method, it will shows you the first 3 items. So the first 3 items you can see here, I said X, STD, the first 3, 0 to 3, the first 3 and all, it gives me the first one is the prediction of the first item. First item is the last one, and the first 2, the last 2 is 0, 0. You can see here the probability, it shows me this one, the second, the last, the first one is this one, which is this, and now here is this, and now here. So what is doing it here is that when we call the argmax, that is we sum and we take the one that is maximum argmax. Remember in NumPy, when we call argmax on this, it will return the probability which is higher. So here when we call argmax on this guy, you can see the argmax on this, it will return which probability is higher. So here you can see it return the position 2. Here 0, 1, 2, which is this guy, and now here it returned the position 0 and 0, 0 in the second and third one. So here that is why you can see we have 0 and 0, and third one is returned the position. So this is called logistic regression, but this is just to show you what is using. But we basically use predict to show us. So predict, we don't even need to call argmax, but Scikit-Learn give us predict function that just return the prediction of which class is that. So we can see the first, we subset the first 3 data set. So the first 3 data set, this is the classes. The first one belongs to the 2. We know what 2 is, right? We know what 0 is. We know what 0 is. 0, I think, is the first one, 2 is the last one, the third one. So that is how we use logistic regression. But if we want to see the prediction of the single item, not these 3 items, so not if you want to predict the class level of a single flower, example, Scikit-Learn expect a 2-dimensional array as data input. Thus, we have to convert a single row slice such as format. So here, if I want to predict the first item, the first flower, Scikit-Learn by default expect 2-dimensional array as input. So we need to reshape this 1-dimensional. So what do we mean by this? Let me show you this guy, the difference. So if we have this guy, you can see this is 1-dimensional, right? But Scikit-Learn expect 2-dimensional. So that is a function of what we call reshape. This reshape, now we say reshape 1 to be 1, and this -1 reshape it to be anything. So you can see now it turns it to 2-dimensional. This is reshape. Can you see that this is showing reshape? Can we see that? Because here is 1 item, it's only 1 item. That is why I have one input. And now here -1 tells me to reshape it into because here I have the number of rows here, the first item here, and now here I have the whole this thing, the prediction. So here it just turn it to it turns this to 2-dimensional. So here, if I just remove this guy, I remove this one, I just run this guy, I will get an error. So you know, if you want to find the prediction of maybe, let's say the second item will be 0, you can see the 0 because this is the second item. Also, if I say the third item, you can see the third item is also 0. So you need to reshape this item so that you can see the prediction of the singles class. So that is it. So we can also see the classification here, classification error, which we already shows, or you can also call prediction accuracy to find which is 0 and find 9. So you can see here in Scikit-Learn, when you learn how to do one thing, just learn the API, you can do any algorithm you call, you can do the same thing. You just need to reiterate. So that is about logistic regression. Tomorrow, I think what we will do is we will go through the other section of the chapter 3, which using SBM, support vector machine, using decision tree to see how we can use these algorithms, Scikit-Learn to explain that. I escaped many theoretical aspects, but it will be good if you can read the book so that you will get a better understanding on how they are implemented in the book. Okay, yeah, so I will share the book in the slide.